Hello, Prep 2. Let's start Unit 2, Lesson 1, which is Properties of Sound Waves. What is meant by sound? Sound is an external factor or stimulus that affects the ear, causing hearing. If I ask you what is the nature of sound, sound is produced due to vibrations of bodies. Sound waves are mechanical longitudinal waves. Mechanical longitudinal waves. Sound waves propagate through media as spheres, whose center is the source of sound. Sound waves consist of compressions and rarefactions. We said that because sound is longitudinal waves. Okay, longitudinal wave. We hear sound from all directions that surround the sound source. Why? Because the sound travels through air as pulses of compressions and rarefactions, whose is the sound source. Sound velocity. Sound velocity is the distance which is covered by the sound waves in 1 second. Sound travels through solids faster than that through liquids, and travels through liquids faster than that through gases. Sound velocity equal wave frequency by wavelength. Properties of sound waves. Sound heard by the human ear are classified into two groups. We have musical tones and noise. Musical tones, they are tones of uniform frequency and comfortable to be heard. Examples such as violin, piano, and reed pipe. What about noise? Noise is the sound of non-uniform frequency and uncomfortable to be heard. Examples, drill, loudspeakers, and horns of cars. The human ear can differentiate between the sounds that reach it through different factors, which are we have sound pitch, sound intensity, and sound quality. Let's start with sound pitch. Sound pitch it is the property by which the ear can distinguish between rough and sharp voices. We have high-pitched sounds and low-pitched sounds. High-pitched sound is sharp, soft, such as sound of women, children, and sparrow. But low-pitched sound is rough, harsh. Examples, men and lion. So it is higher pitch and it's lower pitch. The sound pitch depends on the frequency of the sound source. The relation between the length of the vibrating object and the frequency. By increasing the length of the string vibrating segmented part, so the frequency decrease. By increasing the length of the string, so the frequency decrease. And the sound become low pitched, harsh. What about wind blowing in the bottles illustrated in the opposite figure? In which bottle can you hear a pitched sound and why? From bottle A, yes, from bottle A we hear a high pitched sound because it is of high frequency. As we said, the high pitched sound depends on the frequency, or the pitch of sound depends on frequency. Where frequency increasing by decreasing the length of air column. Okay. Determine the pitch of a tune using Schwarzschild. Schwarzschild it is used to determine the pitch frequency of an unknown tune. Each gear consists of a number of teeth. Each tooth produces a wave. When it touches the metallic plate, number of vibrations waves produce the equal number of cycles, D by number of gears teeth, N. So, sound frequency by Schwarzschild equal number of cycles by number of gear teeth divided time in second. So you have to try to answer this problem by yourself. At the first, calculate the frequency of a musical tune similar to the frequency of a produced tune using Schwarzschild, rotated with a velocity of 960 cycles in 2 minutes, given that the number of teeth of the gear is 30 teeth. Number 2, sound intensity. It is the property by which the ear can distinguish between sounds either strong or weak. Shouting is stronger than whispering. Okay, let us continue in the next video, inshallah, part 2. Thank you.